Welcome back to the lecture series on heat transfer operation. This is Yogesh Lange. In this video, we will learn about the equivalent diameter. Now, what is the equivalent diameter for heat transfer? Or we also call this equivalent diameter as a hydraulic diameter. Now, what is the importance of equivalent diameter and the hydraulic diameter? Now, we know that when we are calculating the Reynolds number, we know the formula of Reynolds number. It is D into U into rho by mu, where D stands for the diameter of the pipe. Where D stands for the diameter of the pipe. Now, it is very easy for us to calculate the Reynolds number if the pipe is circular. If the pipe is circular, we use that equation. But what happens if instead of the pipe, it is a non-circular tube, non-circular pipe? Let's take it is a rectangular one. It is a rectangular duct. Then can we use the same formula to calculate the Reynolds number? Because again, when you are using the various correlations, then for this case, for the internal flow, we should know the Reynolds number, and on that basis we will choose the equation, whether we use the equation for the turbulent flow or for the laminar flow. And the laminar and turbulent flow we are judged on the basis of the Reynolds number, and this is very important for us to calculate first Reynolds number. Once we calculate the Reynolds number, then we will decide whether I use for the Kolben equation, Dittus-Boelter equation, or should I go for the Siderate equation for the laminar case. Okay, and this is very important to know the diameter. So here the concept, if it is a non-circular pipe, that time we first calculate the equivalent diameter. We calculate the equivalent diameter, or in certain case we call it as a hydraulic diameter. So what, when the flow through the non-circular tubes, the Reynolds number as well as the Nusselt number and the friction factor are based on the equivalent diameter. Now when you are calculating the Reynolds number, when you are calculating the Nusselt number, or you are calculating the friction factors, everywhere we need to calculate first a equivalent diameter, which is also called a hydraulic diameter, and the notations is given d e suffix or d suffix h, the equivalent diameter, or we call it hydraulic diameter. Now what is the formula to calculate the hydraulic diameter? The formula is equivalent diameter is the 4 times the cross sectional area divided by the weighted perimeter. It means the D equivalent is the 4 times the cross-sectional area upon the weighted perimeter. Now if it is a rectangular duct, we are taking the cross-sectional area of the rectangular duct, and that we are taking the weighted perimeter. Why weighted perimeter? Whether it is full uh, space is occupied or it is half space is occupied, accordingly we are choosing. Now with the help of the examples, we are taking the 3 different cross sections. The first we are taking for the circular pipe, second we are taking the rectangular duct, and one we are taking the square duct. Let's see what is the equivalent diameter or the hydraulic diameter for this case. Now first, if it is a circular pipe, as we said circular pipe, we choose the dr, inner diameter of the pipe. Let's see with the help of this formula can we get the same one. So see, this is the tube, a circular tube pipe which having the diameter d, and as per our formula, D equivalent is equals to the 4 times the cross-sectional area upon the weighted perimeter. Now the cross-sectional area is what? It is pi by 4 d square is the cross-sectional area of the pipe, and pi d is the weighted perimeter. And if when we are solving this case, we get the value D equivalent is equal to D. It means the D equivalent or the hydraulic diameter for a circular pipe is itself is the diameter of the pipe. Now instead of the circular pipe, if it is a square duct. Now if it is a square duct, and for this case, let's see what is the hydraulic diameter. Now a square duct which having the side A and A. Okay. Now for this case we are writing the formula D equivalent equals to the 4 times the cross sectional area. What is the cross sectional area of the duct? It is A by A. SA into A. That is the A square. What is the weighted perimeter of it? It is the 4 side of the wall. So 1, 2, 3 and 4. That's why 4 times A. And now when we calculate the D is nothing but the D equivalent is nothing but the side of the duct. Means we will take the A as a D for the square duct. Okay. So this is for the square. Now is it a same for the rectangular one? Is it D equivalent equals to the A or the side of the rectangle? And let's see what exactly the value of it. Now we will take a rectangular duct. In this case, see, the side is A and the width is the B, and the fluid is flowing through this duct, rectangular duct. And the formula we have, it is 4 times the cross-sectional area upon the weighted perimeter. Now what is the cross-sectional area for this case? It is side into the width. What is the side? A into the B. So 4 times A into B, this is the cross-sectional area upon the weighted perimeter. Now what is the weighted perimeter here? The two sides, 2 times A plus B. It means A plus B into 2 because they are given the two sides. On that basis, when we find what is the equivalent, now this case, if it is a rectangular duct, for this we have, this is the formula, is 2 times the value of A, value of B upon A plus B, that will give the D equivalent. And now this D equivalent you should put into the either in the Nusselt number formula or for the Reynolds number or for the friction factor. Okay, it means for a circular pipe we have D is equal to D. For the square duct it is D equals to the A, the side of the duct, and here it is D equivalent is nothing but the 2 times the A into the B, the side A and side B upon A plus B. Okay. Now let's see if you want to calculate the D equivalent for the outer pipe. It means let's consider the one of the tube, the fluid is flowing through the tube and another is flowing through the space between these two pipe, which we call the annulus flow. Now when the fluid is flowing between these two, the gap between these two tubes, then what will be the D equivalent? Because here if you see, we can easily find what is the Reynolds number for this case, because it is a circular in nature. But this pipe, though it is a circular in nature, but the fluid is occupied only up to this section. Not full pipe is occupied by the water or by the fluid. Now for this case, we will find first what is the Reynolds number. What is the D equivalent. So for a double tube that consists of the two concentric tubes, for this case, we are considering the concentric annulus of inner diameter Di and outer diameter is DO. The hydraulic or equivalent diameter for this case. I am talking about the fluid which is flowing through the annulus. Okay. So we write the formula. We have the formula for D equivalent is 4 times the cross-sectional area upon the weighted perimeter. For this condition, what is the cross-sectional area? It is 4 into the pi is taken the common DO, that is the outer diameter of the pipe square minus the inner diameter of the pipe, means the fluid which is flowing through this space, upon 4. Upon weighted perimeter is pi into DO plus DI. Now this is the formula for the perimeter and this is the formula for cross-sectional area for this case. I am talking about the fluid which is flowing through the annulus. And for this case, we got the D equivalent is DO minus DI. Now when you want to calculate the Reynolds number of the fluid which is flowing between these two pipe, okay, the space between these two pipe, then we choose the D equivalent is equals to the DO minus DI. Same thing if any cross section any geometry, you just choose the formula for the hydraulic or the equivalent diameter. It is the 4 times the cross sectional area upon a weighted perimeter, and on that basis we can calculate the D equivalent. Okay. So thank you very much for watching this video.